What Ferrari just unleashed could change everything, but will it save their season or expose a deeper crisis? Stay with us, because by the end of this video, you'll understand why this weekend might define the future of Formula One's most legendary team. Subscribe only if you want Hamilton to win his 8th World Championship and be crowned as the greatest driver in history. After months of relentless speculation, whispers from inside the paddock, and subtle teases from the Scuderia's top brass, the long-anticipated, massively ambitious upgrade package for the Ferrari SF25 has finally broken cover, and it's making its debut on one of the sport's most punishing stages, the Bahrain Grand Prix. But calling this moment a simple upgrade, or suggesting it's merely a new set of parts bolted onto an already competent car would be to drastically undersell what Ferrari has just unleashed. This is not a minor adjustment. This is not a reactive, cautious iteration. This is a full-blown, philosophy-altering, direction-defining revolution. One that has been meticulously sculpted behind closed doors and is now thrust into the unforgiving spotlight of Formula One's most intense competition. To understand the weight of this unveiling, we have to look at the context. Ferrari entered the 2025 season with cautious optimism. They had reasons to feel hopeful. The SF25, in its original configuration, was not a failure. In fact, it showed moments of real promise. The car had pace in short bursts. It responded well in qualifying conditions. It had flashes of race-day competitiveness. But there was something missing, something fundamental. The car was inconsistent. Its performance curve fluctuated unpredictably. It struggled in certain temperature windows. Its tire degradation over long stints exposed deep inefficiencies in balance and setup. And most importantly, it couldn't consistently challenge Red Bull, Mercedes, or even McLaren when the race pace truly mattered. What made things more complicated was that these issues weren't always visible from the outside. On paper, Ferrari seemed to be within touching distance. But internally, the team knew they were lacking the robustness required to sustain a title fight. Behind the scenes, engineers, strategists, and data analysts had already reached the same conclusion: small steps wouldn't be enough. A new trajectory had to be drawn. And from that urgent internal realization was born this project, a top-to-bottom reimagining of the SF25, not as a car to evolve, but as a machine to rebuild at its core. Subscribe only if you want Hamilton to win his 8th World Championship and be crowned as the greatest driver in history. The centerpiece of this monumental transformation is a redefined, reshaped, and fundamentally re-engineered tunnel floor, a component that may sound mundane to the casual viewer, but in the current ground effect era of Formula One, it is quite literally the lifeblood of performance. In this generation of regulations, where downforce is generated not by huge wings but by air rushing at unimaginable speeds through sculpted underbody channels, the floor is everything. It dictates stability. It governs tire wear. It influences cornering grip, ride height behavior, and even how the car responds to bumps and curbs. Ferrari's previous floor design, while not a disaster, was simply not delivering the aerodynamic consistency required across different track types and conditions. The airflow wasn't being guided as efficiently as it needed to be. The car would lose downforce when running in turbulent air. It was prone to stall behavior in low-speed corners and lacked peak downforce during high-speed directional changes. In response, Ferrari didn't just tweak the edges. They didn't settle for patchwork solutions. What they've produced is a full-scale architectural overhaul. Every line, every angle, every millimeter of this new floor has been purpose-built. The Venturi tunnels have been entirely reshaped, not just resized, but recontoured to optimize the velocity and pressure distribution along the length of the underbody. Boundary layer control has been re-engineered using innovative strake placements, helping manage airflow attachment in even the most unpredictable corner entries. The rear diffuser has been integrated into this package with new outwash management strategies, allowing for more effective energy recovery from a high-speed airflow exiting the undercarriage. Together, these changes are intended not only to increase downforce but to make that downforce more predictable, more usable, and more resilient to external disruptions. But that's only the beginning. Because a floor redesign of this magnitude does not exist in isolation, it has to be part of a symphony. To support this new aerodynamic concept, Ferrari's engineers have also redefined key elements of the SF25's mechanical structure. The rear suspension has been subtly altered to allow for more adaptive compliance, reducing the sensitivity of the car to vertical oscillations, a crucial factor in making sure the aerodynamic platform remains stable over uneven track surfaces. In addition, ride height management has been optimized via newly tuned hydraulic systems, giving drivers a wider margin for aggressive setups without risking porpoising or loss of underfloor efficiency. Even the cooling architecture has been reconsidered. The engine cover has been reshaped to allow for tighter packaging, which in turn improves the aerodynamic cleanliness of the rear bodywork, reducing drag without sacrificing thermal regulation, a critical balancing act, especially in the heat of desert circuits like Bahrain. Visually, the changes are noticeable to those who know where to look. The floor edges are more sculpted. The rear diffuser sits wider and deeper. The floor fences have sharper angles, and the floor step plane has been subtly raised. These aren't aesthetic flourishes, they're hard-earned engineering solutions, born from months of correlation between CFD simulations, wind tunnel data, and real-world telemetry collected over race weekends. Ferrari hasn't just thrown parts at the car, they've executed a harmonized evolution of the SF25's entire operating philosophy. They've gone from reactive to proactive, from iterative to innovative. But none of this matters if it doesn't translate to lap time. And that's where the pressure now shifts. Bahrain isn't just another track, it's a testing ground disguised as a race circuit. With its mix of long straights, heavy braking zones, high-speed corners, and traction-limited exits, it challenges every aspect of a car's performance. It exposes weaknesses in tire wear. It punishes instability on corner entry. It rewards efficient downforce and punishes drag. If Ferrari's new package is going to prove itself, it will do so here, under the brutal spotlight of a track that leaves no flaw hidden. And that's where the stakes rise from high to astronomical. Because this isn't just about one race. This is about a statement of intent. If Ferrari nails this upgrade, if they find themselves suddenly in contention for pole positions, podiums, and even victories, it sends shockwaves through the paddock. It reshapes the narrative of the 2025 season. It puts Red Bull on notice. It energizes the tifosi. It restores belief inside the garage and lights a fire under a team that has spent too many seasons explaining what went wrong instead of celebrating what went right. But if it doesn't work, if the car still struggles in traffic, if tire degradation remains high, if the gains fail to materialize in the crucial high-speed sectors, then the questions will be relentless. What went wrong in development? Was the philosophy wrong? Is Ferrari chasing the wrong concept? Are they falling behind again? In essence, this is a gamble with no safety net. It's a technological leap taken at full speed, with the hopes and expectations of an entire racing empire riding on its success. Every bolt, every carbon fiber panel, every aerodynamic flick is a testament to Ferrari's refusal to accept mediocrity. They are not content with merely participating in Formula One. They are here to define it, to dominate it, to remind the world why the prancing horse has always been more than just a team. It's a symbol of excellence, of passion, of relentless pursuit of perfection. And now, with the desert sun blazing down on the Bahrain International Circuit and every rival team watching closely from their garages and pit walls, Ferrari steps forward with their most daring, most aggressive, most transformative update in years. It's no longer about what could be. It's about what is. And in this moment, with rubber hitting asphalt and engines roaring at full tilt, the future of their season begins, not with a whisper, but with a thunderous, unmistakable roar. Ferrari's latest wave of aerodynamic upgrades represents not just a set of mechanical tweaks or bodywork adjustments, but rather a comprehensive and deeply considered step forward in their ongoing quest to close the performance gap with the leading teams. At the heart of this update package is a completely reimagined floor design, an area of the car that often escapes the spotlight, yet is arguably one of the most critical aerodynamic zones in modern Formula One machinery. Unlike the upper surfaces, which are more visible and easier to interpret, the floor operates mostly out of sight, yet it's responsible for generating the bulk of the car's total downforce through ground effect principles. The newly designed floor is not merely a cosmetic overhaul, it is likely the product of thousands of hours of computational fluid dynamics, CFD simulations, wind tunnel experiments, and data analysis from previous race weekends. Ferrari's engineers have probably revisited every aspect of the floor geometry, from the leading-edge strakes to the underfloor tunnels, with the aim of optimizing how air is channeled beneath the car and how that airflow interacts with the all-important diffuser at the rear. And speaking of the diffuser, this component has also undergone significant re-engineering as part of Ferrari's upgrade package. In the language of aerodynamics, the diffuser acts as an expansion chamber for the airflow traveling under the car, accelerating the velocity of the air and creating a low-pressure zone that physically pulls the car downward onto the racing surface. This is what engineers call induced downforce, and it is both powerful and efficient. It increases grip without necessarily increasing drag. However, designing an effective diffuser is far from straightforward. Every change in angle, length, or curvature can have far-reaching consequences, especially when it comes to how the car behaves over bumps, curbs, and changes in ride height during dynamic maneuvers. Ferrari's latest diffuser is almost certainly optimized to operate effectively over a broader range of ride heights, which has been a pain point for them throughout the season. The car has frequently struggled with maintaining consistent downforce levels, particularly when the suspension compresses under braking or load transfer through corners. A diffuser that maintains efficiency across this wider operational window can dramatically stabilize the car's aero platform, giving the drivers greater confidence and enabling them to push harder, especially during high-speed cornering sequences where any momentary loss of downforce can lead to lap time losses or even race-ending mistakes. Parallel to the changes made to the floor and diffuser, Ferrari has introduced modifications to the rear wing, another key area where performance gains, albeit more marginal, can be realized. The rear wing assembly includes both the main plane and the increasingly important beam wing, both of which have been revised in subtle but strategic ways. These components serve to generate rear-end downforce and maintain aerodynamic balance, but they also have to minimize drag to preserve straight-line speed. Striking this balance is incredibly difficult, especially in the era of DRS, drag reduction system, where teams must also factor in the aerodynamic behavior of the car when the DRS flap is open. Any change in the rear wing's geometry has to be simulated and tested to ensure that it contributes positively to the car's performance not just in isolation, but in conjunction with the rest of the aerodynamic package. Ferrari's upgrades may include changes to the camber and chord of the main plane, adjustments to the end plate profiles to influence vortex generation, and modifications to the beam wings placement and angle of attack to refine how air exits the rear of the car and feeds into the wake. These details might sound arcane, but they are essential in shaping the aerodynamic fingerprint of the vehicle, how it cuts through the air, how stable it feels in yaw, lateral motion, and how it manages tire temperatures over long stints. And while changes to high-profile components like the diffuser and rear wing get most of the media attention, Ferrari has also chosen to focus on a component that, to the untrained eye, might seem almost irrelevant: the rear brake duct assembly. In reality, this is one of the most aerodynamically sensitive and multifunctional parts of an F1 car. Yes, the primary function is to channel cool air onto the brake discs and calipers, preventing overheating and fade, but that's only a small part of the story. These ducts also play a crucial role in managing the turbulent air that flows around the rear wheels, air that, if left uncontrolled, can wreak havoc on the car's aerodynamic consistency. The rotating tires generate unpredictable wake patterns that disrupt rear downforce and increase drag. Ferrari's new brake ducts are likely designed with complex vanes and sculpted inlets that not only improve cooling efficiency but also condition and redirect this turbulent air in a way that improves the downstream airflow. This results in a more predictable aerodynamic environment for the rear wing and diffuser to operate in, thus enhancing overall vehicle stability and rear-end grip. Moreover, by refining airflow around the wheels, Ferrari can also reduce tire degradation, which has been another Achilles heel in races where managing tire wear is crucial for a successful strategy. But let's take a step back. What exactly is Ferrari aiming to achieve with this extensive and layered suite of aerodynamic updates? Interestingly, their goal doesn't appear to be the simple pursuit of more raw downforce, which is often the default assumption when any team unveils a major update. Instead, the upgrades seem to be laser-focused on two deeply intertwined and strategically vital attributes: stability and drivability. These are not just engineering buzzwords, they are performance characteristics that dramatically influence how a Formula One car behaves throughout an entire race weekend, from the very first free practice session to the final lap of the Grand Prix. Stability, in this context, refers to how predictably the car responds to inputs from the driver, especially under extreme conditions like heavy braking into a chicane, rapid direction changes in a complex like Silverstone's Maggots Beckett's, or flat-out high-speed sweeps like those seen in Suzuka. An unstable car might produce impressive downforce on paper, but if that downforce fluctuates with every bump or minor steering correction, the driver will never feel confident enough to explore the limits of the car's capability. Drivability, meanwhile, is a more nuanced but equally critical attribute. It encompasses how seamlessly the car performs across a wide range of scenarios: different fuel loads, changing tire conditions, variable wind directions, and evolving track grip. A car with high drivability is one that responds consistently regardless of these external variables. It allows the driver to maintain rhythm and pace without having to constantly adapt to unpredictable balance shifts, snap oversteer, or loss of rear grip under acceleration. These small inconsistencies might seem manageable in isolation, but over the course of a race, they sap the driver's mental focus, increase the risk of errors, and make strategic tire management far more difficult. In short, a car that is stable and drivable is a car that can extract its full potential over an entire stint, across multiple race weekends, and in the hands of different drivers. Ferrari's engineering team appears to be targeting precisely this kind of performance ceiling. Not a one-lap wonder or a car that dominates in ideal conditions, but a well-rounded machine that performs reliably in the real-world chaos of Formula One racing. Every component in this update, from the floor and diffuser to the rear wing and brake ducts, has been meticulously rethought with this strategic aim in mind. And if these upgrades deliver as intended, we may be looking at a pivotal moment in Ferrari's campaign. A turning point where the car finally becomes not just fast, but also trustworthy, predictable, and potent enough to challenge for consistent podiums, if not victories. The question now is whether these theoretical gains will translate into on-track results in the heat of competition. But if the data is right and the philosophy sound, Ferrari could be on the verge of a significant resurgence, driven not by bold reinvention, but by intelligent refinement. Ferrari's 2025 Formula One campaign has been marked by a complex, deeply frustrating technical flaw that, while almost invisible to the naked eye, has had cascading consequences for the performance, reliability, and competitiveness of their SF25 Challenger. The issue revolves around the car's ride height, a detail so minute that it borders on the imperceptible. Yet in Formula One, especially in this new generation of ground effect machines, even the tiniest deviation can unravel an entire concept. The SF25 is running roughly 3 mm higher than the original design parameters anticipated, and while that figure may sound negligible to a non-engineer or casual fan, the ramifications are nothing short of seismic within the hyper-precise world of Grand Prix racing. To understand the severity of this issue, one must first grasp the foundational principles of modern Formula One aerodynamics. The cars are no longer simply reliant on wings to create downforce. Since the 2022 regulations overhaul, teams have been exploiting the underfloor and venturi tunnels to generate what's known as ground effect. This design philosophy centers around manipulating airflow underneath the car to create low pressure, effectively sucking the car toward the track and increasing grip without necessarily increasing drag. For ground effect to work properly, the floor of the car needs to be as close to the tarmac as physically possible without actually making contact, especially in high-speed corners, where downforce is most critical. When a car sits too high, even by a mere 3 mm, it disrupts this delicate aerodynamic dance. The underfloor can't seal correctly, vortices don't behave as predicted, and the entire system loses efficiency. The suction effect is reduced, the rear becomes unstable, and the balance of the car deteriorates, particularly during sustained high-speed load changes. Ferrari's original concept for the SF25 assumed a natural squatting behavior at high speed, something that would compress the suspension, lower the ride height, and allow the car to sit into its optimal aerodynamic window. The theory behind this approach is sound. Many teams pursue a similar objective: build a stiff but responsive chassis and suspension that can dynamically adapt under load, providing a stable aerodynamic platform through corners and straight-line sections alike. But for Ferrari, the transition from theory to practice hasn't gone smoothly. For reasons still being investigated, though believed to involve a combination of overly stiff suspension geometry, chassis limitations, and perhaps an overestimation of the car's dynamic behavior in simulation environments, the SF25 simply isn't settling into its intended ride height when pushed to the limit. Instead of compressing as expected at high speed, the car maintains a ride height that is slightly too elevated, just enough to push the entire aerodynamic system out of its ideal operational envelope. The consequences of this flaw manifest themselves in multiple ways across a Grand Prix weekend. During qualifying sessions, when the car is running light on fuel, shod with soft tires, and set up for maximum attack over a single lap, the SF25 can occasionally mask its underlying issues. In these conditions, it comes tantalizingly close to the performance window it was designed for. There are glimmers of speed, flashes of brilliance, brief moments when the car looks balanced and fast, especially on smooth circuits or in cool temperatures where grip is naturally higher. But as soon as race day arrives, with full fuel loads, increased tire wear, evolving track conditions, and the need for long-run consistency, the car's limitations come into sharp relief. The rear end becomes nervous, the tire degradation rate increases, and the balance shifts unpredictably from corner to corner. Ferrari's drivers, Charles Leclerc and Carlos Sainz, are left managing a car that demands constant compromise: brake earlier, lift mid-corner, delay throttle application, or risk oversteer and excessive tire temperature buildup. Over the course of a race distance, this instability costs lap time, increases stress on the tires, and forces the team into more conservative strategies just to maintain competitiveness. A recent example of this painful contrast was seen during the Chinese Grand Prix sprint weekend. In the sprint race format, shorter, faster, with fewer variables, Lewis Hamilton managed to capitalize on Mercedes' strengths and secure pole, holding off the field with confidence. Ferrari, by contrast, looked more competitive in the early laps, when the car was still light and the tires fresh. But the cracks began to show quickly. The car's inability to remain consistently within its optimal ride height window once again undermined its potential. What could have been a strong podium contending performance in the sprint faded into a disappointing result. And this wasn't an isolated case, it's a pattern that has repeated itself at multiple circuits so far this season. What's even more concerning is the quantifiable performance gap that this flaw has introduced. According to a comprehensive technical analysis conducted by Autorayer, a well-regarded motorsport data publication, Ferrari is currently losing up to 20 points of aerodynamic load under race conditions compared to rivals such as Red Bull and McLaren. In Formula One terminology, aero load refers to the downforce generated by the car's entire bodywork and underfloor. Losing 20 points of this load is catastrophic. It's the kind of deficit that shows up everywhere: in lap time, in top speed, in tire wear, in cornering speed, and even in driver confidence. When a driver feels the rear stepping out unpredictably or notices a lack of front end bite entering corners, they begin adjusting their style, usually by backing off. And in Formula One, backing off for even a tenth of a second per lap is often enough to lose track position, fall out of DRS range, or fail to defend from a charging competitor. Over a full race, this amounts to multiple seconds lost and frequently, a drop of several positions from the grid spot earned on Saturday. The mental toll on the drivers cannot be understated either. Both Leclerc and Sainz have expressed frustrations, albeit diplomatically, in post-race interviews and press briefings. It's clear they know the car is capable of more, that the performance ceiling exists, but remains frustratingly out of reach. And for a team as storied and historic as Ferrari, the burden of underperformance weighs heavily not only on the drivers, but across every level of the organization. Engineers, aerodynamicists, and strategists work relentlessly back at the factory to decode telemetry, refine simulations, and build new parts that can address the ride height discrepancy. The pressure to deliver results is constant, and it only grows more intense with each missed podium and each race weekend where rival teams extend their advantage. In light of all this, Ferrari's response has been swift and aggressive. They have greenlit a comprehensive upgrade package, one of the most ambitious mid-season revisions the team has undertaken in recent memory. This package is not a superficial tweak or minor evolution. It's a fundamental rework of multiple aerodynamic components, suspension elements, and possibly even floor geometry to realign the SF25 with its original design goals. And crucially, Ferrari has chosen to introduce this new package at a circuit where they already possess an abundance of relevant data collected during winter testing. The decision to debut the upgrades at a familiar track is strategic. By minimizing the number of unknown variables, they can more accurately measure the direct impact of the changes and compare new telemetry against a reliable baseline. This upcoming Grand Prix could therefore become a pivotal moment in Ferrari's season. It's not just another race, it's a litmus test. It's an opportunity to prove that the team still possesses the agility, creativity, and technical precision to correct course mid-season and mount a serious challenge against the sport's frontrunners. Every lap will matter. Every micro-adjustment in the garage will be analyzed. Every word in the driver's feedback will carry weight. Because if the upgrade works, if the SF25 can finally operate at the ride height it was designed for, then Ferrari might be back in the fight. But if it doesn't, then serious questions will start to arise about the team's development philosophy, simulation accuracy, and long-term trajectory. One thing is certain: the spotlight is on Maranello, and the whole world will be watching. There are moments in Formula One where a team's decision, one that might seem subtle or even routine on the surface, reveals itself with time and context to be an act of calculated brilliance. Such is the case with Ferrari's choice to debut their highly anticipated SF25 upgrade package at the Bahrain Grand Prix. At first glance, it's simply the first round of the season to introduce new components. But peel back the layers, and you begin to see how this decision is not only rooted in engineering logic, but is also infused with tactical foresight and a deep understanding of how performance evolution is best measured in a sport where variables often cloud the truth. Bahrain is not just another racetrack. It's a data-rich environment, a known quantity in an unpredictable championship. The Scuderia isn't just using Bahrain as a place to run their latest upgrade. They're using it as a proving ground, a living laboratory, a controlled experiment where the conditions, the telemetry, and the benchmarks are already baked into the team systems. With pre-season testing having taken place on this exact same circuit just weeks prior, under similar weather conditions, comparable asphalt temperatures, and with the same layout, Ferrari has a golden opportunity to evaluate the effects of their upgrades with unprecedented clarity. It's like having a before and after snapshot under controlled lighting, the perfect scenario for engineering comparisons. If everything goes according to plan during the free practice sessions, and both Charles Leclerc and Lewis Hamilton are able to complete uninterrupted runs on Friday, without traffic interference, mechanical issues, or red flags, then the technical team at Ferrari will gain access to one of the most comprehensive and revealing datasets they'll see all season. This is no small advantage. It allows the engineers to dissect the differences between the original SF25 configuration and the newly upgraded version down to the most granular level imaginable. They'll examine tire degradation curves across multiple compounds, determine how rear-end stability has changed under high braking loads, assess whether corner exit behavior is more predictable, and quantify fuel consumption deltas over race-length simulations. In addition, they'll analyze sector-by-sector telemetry to assess how the car's balance, downforce levels, and straight-line speed have evolved, all while cross-referencing that against wind tunnel predictions and simulator feedback from both drivers. But this isn't merely about raw lap time. That's the most visible metric to fans and media, yes. But within the paddock, what matters just as much, if not more, is the overall quality of that lap time. Ferrari isn't just chasing a few tenths on the stopwatch. They're chasing predictability, drivability, and operational ease across an entire race weekend. A car that is easier to drive consistently across all three sectors, through a full tank of fuel, under tire degradation and heat cycles, is one that allows a team to unlock every layer of potential it holds. And that's what these upgrades are targeting. This data will help inform not only the car's setup on a weekend-by-weekend basis, but also the direction of future updates, both short-term and long-term. It will allow engineers to make more intelligent decisions about which design paths are worth pursuing and which ones are dead ends. It will empower them to anticipate how the car will behave under certain conditions, rather than simply reacting to what happens during a session. And for the drivers, who live and breathe confidence behind the wheel, this growing understanding of the car's personality can be transformative. A car that becomes predictable is a car that becomes trustable. And a car that a driver trusts is a car that can be pushed to its absolute limits with conviction, lap after lap. It's easy to think of upgrades as being solely about lap times, about slicing a few tenths off here and there. But the true power of an upgrade lies in the transformation it can trigger in a team's operational rhythm. The synergy between departments tightens. The communication between driver and race engineer sharpens. The quality of feedback improves. The ability to execute race strategy becomes more precise. And the confidence of the entire organization starts to rise, not because they've suddenly become dominant, but because they can see, in real time, that the tools they're building are starting to work, and that the car is evolving in the right direction. But of course, there is another side to this story. A darker, more sobering possibility that cannot be ignored. What if the upgrade doesn't work? What if, despite all the months of design work, all the hours spent in simulators, and all the faith placed in computational fluid dynamics and wind tunnel modeling, the SF25 still refuses to behave as intended? What if the rear instability continues to plague corner exits, if tire degradation continues to spike after just a few laps, and if the drivers continue to complain about a car that feels twitchy, unpredictable, and fundamentally difficult to extract performance from? In that scenario, Ferrari faces a brutally difficult decision. One that no team wants to confront, but which is unavoidable when aspirations meet reality. Do they double down on a flawed concept, committing even more time, money, and resources into trying to correct something that may be fundamentally compromised? Or do they make the hard call to lock down development of this car, accept that 2025 might be a transitional season, and shift their entire focus toward the massive technical reset that is coming in 2026? This is not just a technical dilemma. It is a philosophical one. It is a test of Ferrari's leadership, their vision, and their willingness to act decisively under immense pressure. Abandoning a current project mid-season is never easy, especially not for a team with Ferrari's legacy and global expectations. It can be perceived as surrender, as a failure to deliver. But persisting with a flawed platform also carries risks, chief among them being the loss of competitive ground to rivals who may already be focusing more effectively on the long-term picture. And make no mistake, 2026 is coming fast, and it is going to change everything. With entirely new power unit regulations, simplified aerodynamics, and a return to a more sustainable, efficiency-focused design framework, the next generation of Formula One cars will bear little resemblance to what we see on the grid today. Ferrari knows this. Every team knows this. And that's why the strategic calculus is so complex. The deeper Ferrari goes down the development path of the SF25, the more they risk stretching themselves thin. The more they commit to trying to extract performance from a platform that may already be fundamentally limited, the less time, focus, and energy they'll have to dedicate to building a future contender under the new regulations. This is the balancing act that defines modern Formula One. It's a sport of margins, between success and failure, between boldness and recklessness, between present priorities and future potential. And this is why this weekend's Grand Prix in Bahrain carries a significance that far outweighs the 25 points on offer for a race win. This is Ferrari's proving ground. This is the weekend where decisions will start to crystallize, where the effectiveness of their current philosophy will be tested under race conditions, and where the results, whatever they are, will echo through every corridor of the Maranello facility. Behind every component on that car is the work of hundreds of engineers, designers, strategists, mechanics, and visionaries. Every gear shift, every throttle input, every telemetry spike represents the culmination of months of effort, planning, and belief. The weight of those expectations is immense. It is not just a race for Charles Leclerc and Carlos Sainz. It is a race for every Ferrari employee. It is a race for every fan in red across every grandstand and living room around the world. It is a race for the soul of a team that has endured decades of glory and heartbreak in equal measure. The stakes could not possibly be higher. This is not just about fighting for a podium. This is about fighting for identity, for relevance, for redemption. This is about proving that Ferrari can once again be more than a symbol, they can be a force. That the prancing horse still has the strength to gallop with the best in the world. And while we may not know the full consequences of what happens this weekend until many races from now, we can already feel the tension, the electricity, the pressure. This is not a normal race weekend. This is a moment of truth, a turning point, a spark that could ignite a resurgence, or confirm the need for reinvention. Whatever happens in Bahrain, one thing is certain: Ferrari's journey through the 2025 season will be defined not just by performance metrics or championship standings, but by how they respond to this challenge. With courage, with clarity, and with the relentless pursuit of excellence that has always defined the heart of Scuderia Ferrari. If the package works as intended, if the wind tunnel figures match real-world performance, if the CFD simulations aren't betrayed by track reality, then the benefits could be exponential. The car might not only be quicker, but also more composed in high-speed corners, less sensitive to crosswinds, more forgiving over curbs, and less prone to understeer or snap oversteer in transitional corners. That matters enormously in Bahrain, where rear traction and braking stability into tight corners like turns 1 and 10 are critical. A car that handles these zones more smoothly allows the driver to brake later, get on the throttle earlier, and carry more speed with confidence, without sacrificing tire life or inviting mistakes. For Charles Leclerc, who has often been forced to wrestle with a car that teeters on the edge of control in high-speed corners, a more compliant rear end could unlock consistency across race stints. For Lewis Hamilton, whose driving style favors a stable platform that allows for fine modulation of throttle and steering inputs, these upgrades could translate into reduced driver fatigue and sharper racecraft, particularly in wheel-to-wheel battles where positioning and confidence under braking are everything. Then there's strategy. If the upgrades deliver improved tire wear, especially on the rear tires, which suffer significantly in Bahrain's abrasive, traction-heavy layout, Ferrari could approach Sundays with an entirely new playbook. They could commit to aggressive undercut strategies without the fear of early degradation, or opt for longer opening stints that keep them flexible against rivals reacting to safety cars or unexpected weather changes. The mental and tactical load lightens when you have a car that behaves predictably and responds to setup changes cleanly. Suddenly, the team isn't just surviving through races, they're dictating terms. But as always in Formula One, for every ounce of hope, there is a matching dose of uncertainty. Perhaps the most compelling and suspenseful question is the simplest, yet the hardest to answer. How much time does this upgrade actually deliver? Is it worth 3/10 per lap? 5. Could it be as much as 7 or 8 in qualifying trim? The truth is, even Ferrari's most senior engineers won't have that answer until they complete qualifying simulations on low fuel and soft tires, and until they see how the package holds up across an actual race distance under full fuel load, variable wind conditions, and live traffic. In the best-case scenario, the kind of best case that engineers whisper about but rarely voice, this upgrade could be more than just a step. It could be a leap. Ferrari might move from being a clear fourth-best team behind Red Bull, Mercedes, and McLaren to suddenly challenging the likes of Aston Martin and McLaren on raw pace. That alone would be a narrative shift. But the most intoxicating scenario is the one no one dares to say aloud, that on certain tracks, in specific conditions, Ferrari might start nibbling at Red Bull's heels. Because if the SF25 becomes more stable, more efficient, more adaptable, and if Red Bull begins to show even the slightest cracks in its armor, then this season's title fight could stretch wider than anyone imagined. And that's the magic of an upgrade. It's not just carbon fiber and numbers on a spreadsheet, it's possibility. It's the hope of transformation. It's the moment when a team that has spent months in wind tunnels, design rooms, and simulation labs finally gets to see whether the vision they've been chasing in theory actually comes to life in reality. It's the culmination of sleepless nights, endless meetings, rigorous debate, and that persistent obsessive question every engineer lives by: what if we can be faster? What if this is the breakthrough? So, as Ferrari rolls their Scarlet cars onto the Bahrain International Circuit, bolted with new parts and brimming with new intent, it's not just about what's visible to the naked eye. It's about what's been building in the shadows. The data, the pressure, the hunger. And whether it all translates into a car that's not just better, but good enough to change the course of a season. Because in Formula One, sometimes the difference between fighting in the midfield and fighting for glory isn't a second. It's a tenth. And sometimes, all it takes is the right upgrade at the right time, in the right place, to ignite the fire. Even if the complete and absolute performance ceiling of Ferrari's latest upgrade package isn't fully realized or demonstrated during this particular race weekend, the broader long-term implications of introducing such a comprehensive set of changes could be monumental for the team, not just this season, but for the structural direction of their Formula One project as a whole. This isn't merely a temporary adjustment or a minor performance tweak aimed at securing a few extra points in a single Grand Prix. What Ferrari is undertaking here is the early phase of what could become a fundamental redefinition of how they conceptualize, develop, and execute their racing strategy, their design philosophy, and their technological evolution. When a team like Ferrari, one of the most historically significant and passionately supported teams in the world, rolls out a major update to its car, the ripple effects reach far beyond the confines of the paddock. We are talking about a developmental philosophy that has the power to alter not just performance metrics on track, but also internal dynamics within the organization, future staffing priorities, allocation of wind tunnel hours, budget cap resource distribution, and even the way data flows through the feedback loop between drivers, engineers, and aerodynamicists. Every change, every new part fitted onto the SF25, is an opportunity to gather a different set of data, to interpret new telemetry patterns, and to refine Ferrari's understanding of their car's behavioral identity across varying track conditions, tire compounds, fuel loads, and driver inputs. This weekend is not about immediate validation or instant gratification. It's about initiating a process, an iterative, data-driven journey that could reshape Ferrari's approach to performance optimization. The more track time they get with this revised SF25, the deeper their understanding will become. With every stint, every long-run simulation, every qualifying attempt, they are collecting invaluable information that can help them isolate where performance is gained or lost, where airflow is inconsistent, where the suspension geometry helps or hinders, and where downforce delivery becomes unstable. Over time, this accumulation of knowledge becomes a strategic weapon, a competitive edge that might not appear flashy on paper, but which builds over race weekends, subtly and silently, until it becomes a decisive advantage.